Back to massage with Dr. Clark. Today, we're going to be looking at a phenomenon called the photoelectric effects. This was this was explained by Einstein. Now, it existed previous to Einstein, so he didn't discover it. Well, it's a very fascinating phenomenon. So if we have this, we're gonna make a circuit with some metal electrodes. I think envision a wire, and then there's ammeter, which measures electric currents. So if we shine some lights, it's whatever lights, if the light has the appropriate frequency for this metal, whatever the metal is, let's say the metal is copper or iron or zinc, then if light is at or above threshold frequency of metal, electrons will be ejected and completes the circuits. Only the light is at or above the threshold frequency of the metal electron, the metal. Right? So below this frequency, nothing's going to happen. So let's say this is below threshold frequency, call it TF. So I'm going to draw another diagram. So my metal is equal to threshold frequency. My ammeter, or could use a light bulb, is going to detect electric currents because my electrons are now going to get ejected and they're going to complete the circuit. So what the importance of this discovery was that electrons are particles, so they have mass, not a bunch of mass, like a lot of mass, but they still have mass. So the fact that light can, with on the right frequency, can eject these particles, that must mean that light must have some particle nature of its own. So we call it a dual nature of light. It's a wave and a particle because it can essentially exert momentum and bounce these electrons out of the metals. And also, something else it kind of started to introduce was that matter, these metals, since they all have their own threshold frequencies, they must have some specific electronic arrangements based on energy. Because if we know the threshold frequency, we can figure out the energy, right? Using it equals H times frequency, that equation. So there must be some order of the electrons in these metal atoms. Yeah, so Einstein explained this. So the photoelectric effect, you can see that with garage door openers. So you notice if your garage door is coming down and you kind of put your hand or your foot under it, it will stop because there's a beam of light that gets interrupted. And that is an application of the photoelectric effect. All right, so just wanted to talk about that briefly. Until next time, Officer with Dr. Clark.